Hello all, welcome to Achievers Hub. From today onwards, we will be starting the similar triangles chapter for class 10th. Okay, so first we will see what are similar triangles or what are similar figures. Any figure which have the same shape is called similar. Okay, see here two triangles which are of similar shape, they are called similar and it is a triangle. Now a circle can also be similar because it is in the form of a circle. A circle is not similar to a square. These are not similar. Okay. What are similar? A triangle is similar to a triangle. A circle is similar to a circle. But a circle is not similar to a square. That means for similar triangles, we are using the same type of figures. Now here we will be dealing with the triangles only. Now if we see, it is a right angled triangle. It is similar to this right angled triangle, but the measurements of the sides are different. The measurements of the sides are different. Then how can we say they are similar? Because the angles are equal. And the second thing is, when a figure is similar, then the ratio of the angles, suppose it is A, is B and it's C, and here D, E, F, then the ratios are in equal proportion. Then we say that both the figures are similar. Okay. Now we will take another example. Here triangle ABC, which is right angled at B, and triangle DEF, which is right angled at E, if it is given that angle B is equals to angle E and angle A is equals to angle D, then automatically angle C will become equal to angle F. Why so? Because the angle sum property says that 180 degree is equals to angle A plus angle B plus angle C. Similarly, it will also be equal to angle E plus angle F plus angle D. Now we are already given that B is equal to E, therefore it will be cancelled out. A is equal to D, A and D will be cancelled out, therefore angle C will become equal to angle F. And we say that by AA similarity, angle similarity, triangle ABC is similar to, the similarity, the sign for similarity is the sleeping S, is similar to triangle DEF. So I hope till now you have understood what is a similar figure and what is a similar triangle. All circles are similar to each other. All right angled triangles are similar to right angled triangles. All squares are similar to each other. All rectangles are similar to each other. Now we will be dealing with BPT theorem. The BPT theorem or basic proportionality theorem. The basic proportionality theorem. The basic proportionality theorem states that if a line is drawn parallel to one side of a triangle to intersect other two sides in distinct points, then the other two sides are divided in same ratio. That means here DE is parallel to BC. Okay. Similarly, if I draw a line like this, okay, and I name it F and G. FG is parallel to AC. We can also take that ratios also. Similarly, I can draw some other line H and I. Okay. H and I is parallel to AB. That means any line which is parallel to the one side of a triangle, the ratio of the sides becomes equal. Okay. So now here I have drawn what? DE parallel to BC. Then DE is a line which is intersecting AB and AC at D and E. Now, which ratio will be equal? AD by DB is equals to AE by EC. Okay. This is the first and most important result of this theorem. Okay, there are some other corollaries also. What are those? Those are the results which are derived from this result. Now if I add 1 to both sides, okay, if I add 1 to both sides, then AD plus DB, what will it become? AD upon DB plus DB is equal to AE plus EC upon EC. Or we can say that if I add 1 to this, AD plus by DB plus 1 is equal to AE by EC plus 1. I think it is not visible, that's why I have written over here. AD plus DB upon DB is equal to AE plus EC upon EC. Now what is AD plus DB? It becomes AB by DB is equal to what is AE plus EC? It becomes AC by EC. This is the second result which we can derive from this equation. If I take the reciprocal, then what I will be getting? I will be getting DB by AB is equal to EC by AC. That is the third result which I have derived from the given equation. Similarly, I can take reciprocal, I can add 1, or I can even take the ratio of the smaller triangle to the bigger triangle. So this is the basic proportionality theorem. You have to write the reason that every time in the if the question is asked in the exam, you can write the reason, or you can simply write BPT or Thales theorem. It states that if a line is drawn parallel to one side of a triangle and intersecting the other two sides at two distinct points, then the sides are divided in the ratio which is equal. Okay, now we will be seeing converse of BPT theorem. Let us once again rewrite the three results. Okay, I am erasing it. Now, first one what we have wrote, AD by DB is equal to AE by EC. This is the one which will be proved using the BPT theorem directly. Second one is after adding 1, we have got the result AB by DB is equal to AC by EC. This is the second result from the given equation. Okay, and now the third one, that is DB by AB is equal to EC by AC. This is the third one by taking reciprocal of the second equation. Similarly, in few questions you have to add 1, or in few questions you have to take the ratios of the smaller triangle to the bigger triangle. Okay, and now we will go on to converse of BPT theorem. Now let us see converse of BPT theorem. The converse of BPT theorem states that if a line divides the two sides of a triangle in the same ratio, that means here the ratio is already given. If the line divides the two sides of a triangle in the same ratio, then the line is parallel to the third side. That means in this question, AD by DB is equal to AE by EC, the theorem. It is already mentioned that the ratios are equal. If the ratios are equal, then DE will be parallel to BC. This is the converse of basic proportionality theorem. What is the basic proportionality theorem? Let us revise it one again. That if two lines are drawn parallel, a line is drawn parallel to one side of a triangle, then the line divides the sides of other two sides of the triangle in equal ratio. And what is converse of BPT? That if the ratios are equal, then the lines are parallel. Okay. So now we will be using these two theorems to solve few questions. And now we will be going on to the first question of the exercise. So the first question from exercise 8.1, similar triangles, class 10th. The question states that in triangle PQR, ST is a line such that PS by SQ is equals to PT by TR. Okay, and we have angle TSP is equal to angle PRQ, and we have to prove that triangle PQR is isosceles. Okay, so the given I have written here the given values, that is PS by SQ is equals to PT by TR and angle PST is equals to angle PQR. And we have to prove that triangle PQR is isosceles. That means angle Q is equals to angle R we have to prove. Okay. Now, as we know that here for proving the triangle is isosceles, we have to prove that angle Q is equals to angle R. Now we will take in triangle PST and triangle PQR. Okay. Angle P is equals to angle P, which is common, and angle S is equals to angle R given. Therefore, by AA similarity, angle PST is equals to angle PQR. Both the triangles are similar. And we know that when two triangles are similar, then we can use the BPT theorem. Now, here already it is given that PS by SQ is equals to PT by TR. Therefore, ST will be parallel to QR by converse of BPT. So, by converse of BPT, as ST is equals to QR, therefore, these two angles, angle S and angle Q, will be equal. Why? Because they are corresponding angles. When corresponding angles are equal, the lines are parallel. So, when lines are parallel, the corresponding angles are equal. Therefore, angle S is equals to angle Q. Now, we have already been given that angle S is equals to angle R. Therefore, we will be given this as 1 and this as 2. Then, from 1 and 2, angle S is equals to angle Q is equals to angle R. Therefore, angle Q is equals to angle R, which gives me that angle Q is equals to angle R. Therefore, triangle PQR is isosceles, which is the thing we are required to prove in the given question. Okay, let us see once more. In the question, it is given that PS by SQ is equals to PT by TR. Okay, when PS by SQ is PT by TR, then by converse of BPT, ST becomes parallel to QR. When ST becomes parallel to QR, when two lines are there, this is a transversal, the angle S and angle Q will be equal due to corresponding positions, and the angles are called corresponding angles. Angle S is already been equal to angle R. Why? It is given in the question. Angle PST is equals to angle PRQ. Now from 1 and 2, we are given angle S is equal to angle Q is equals to angle R. Therefore, angle Q is equals to angle R, and the triangle has become isosceles because two of the opposite angles are equal. Okay, now we will move on to second question. The next question, exercise 8.1, question number 2. In the given figure, LM is parallel to CB, LM parallel to CB, CN parallel to CD. Sorry, LN parallel to CD. LN parallel to CD. And we have to prove that AM by AB is equal to AN by AD. Okay. Now, as it is given that LM is parallel to CB, we can use the BPT theorem. And again it is given that LN parallel to CD, we can again use the BPT theorem. So, if I will be using the BPT theorem in triangle AML and triangle ABC, okay, then in BPT theorem we will be taking only one triangle. Therefore, in triangle ABC, ML parallel to BC, it is given. Therefore, AM by MB or is equals to AL by LC, or we can take AM by AB is equals to AL by AC. Okay, I have already explained in BPT theorem that we can take the values like this. Okay, now again in triangle ADC, okay, AN by ND is equal to AL by LC, or AN by AD is equals to AL by AC. Let us give this point 1 and this equation 2. Then by comparing or by equating, by comparing equation 1 and 2, 1 and 2, we can see that AL by LC is common in both the equations. Therefore, AL by AC is equals to AN by AD is equals to AM by AB. Which is the thing we are asked to prove, that is AM by AB is equals to AN by AD. Okay. So, we can take the result as AM by AB is equals to AN by AD. Okay. Hence, proved. And one thing more, here we have written ML parallel to BC, which is given, and we can write it as by BPT. Similarly, here also we can write in ADC LN parallel to CD. The reason is given, and by BPT the ratios are equal. Okay. Once again, let us see the question. We have to prove AM by AB is equals to AN by AD. We have taken triangle ABC and we have applied BPT and we got this ratio. And in triangle ADC, we have applied BPT and we have got this ratio. And by comparing equation 1 and 2, we have got the result which was required to prove. Okay. So, let us move on to third question. The third question states that in the given figure, DE parallel to AC and DF parallel to AE. And we have to prove that BF by FE is equal to BE by EC. Okay. So, now first we will take triangle ABC and parallel line DE and AC. When we will be taking A, B, C, here the parallel line is DE parallel to AC, which is given. Therefore, by BPT, BD by DA is equals to BE by EC. Or I can write it as BD by AB is equals to BE by BC. Okay. By BPT. By BPT. Okay. Now, next in triangle DF parallel to AE. DF parallel to AE. Therefore, triangle BAE. In triangle BAE, BD by DA is equals to BF by FE, or BD by BA is equals to BF by BE. Okay. Now, let us take this as 1 and this as 2. On comparing equation 1 and 2. Here the reason is by BPT. Okay. By comparing 1 and 2, we can see that we are having BD by AB or BD by BA. AB or BA is the same thing. Therefore, BD by BA is equals to BE by BC is equals to BF by BE. Okay. First thing. Second thing, BD by DA is equals to BE by EC, which is also is equals to BF by FE. This is the thing which is required to prove. BD by DA is equals to BE by EC is equals to BF by FE. Okay. Here you can see BF by FE is equals to BE by EC. BF by FE, that is BE by EC is equals to BF by FE. We have to prove BF by FE is equal to BE by EC. Therefore, the result here comes out BF by FE is equals to BE by EC. Okay, which is that we are asked to prove, hence it is proved by using BPT. Therefore, in this question we have taken two triangles and two different results, and we have equated the result and we got the desired result which is asked in the question. Okay, now we will move on to question number 4.